In this video, we will write systems of inequalities, solve them by graphing, and identify the possible solutions. So in each of these problems, we're going to have a situation that we have to write the system from, graph the solution with our shaded region, and write two possible solutions. So let's read through this situation here. Suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound, and cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. So let's go back through and let's highlight our important information. Flour costs $1.50 per pound. Cornmeal costs $2.50 per pound. We're going to spend less than $25 on both, and we need at least 6 pounds altogether. So let's write our let statements first. We're talking about two different quantities, the amount of pounds of cornmeal and the amount of pounds of flour. So we're going to let our x be our pounds of flour, our y be our pounds of cornmeal. That means that our x and y axis are going to be pounds of flour and pounds of cornmeal. So now let's go back to our situation and write our inequalities. We know that we need at least 6 pounds altogether. So the amount of pounds of flour and the amount of pounds of cornmeal have to be at least 6. At least means we can't have lower than 6. So x plus y, the amount of pounds we have, has to be greater than or equal to 6. And since we know flour costs $1.50 per pound and cornmeal costs $2.50 per pound, we know that we're going to have $1.50 times x and $2.50 times y. But we don't want to spend more than $25. We want to spend less than $25. So $1.50 times the number of pounds of flour we buy plus $2.50 for the amount of cornmeal has to be less than or equal to 25. After I convert both of these inequalities, to our slope-intercept form, I have y is less than negative 3/5 x plus 10, and y is greater than or equal to negative x plus 6. Now I can use these equations to graph. So once I have them graphed, I can see my shaded region. We have greater than negative x plus 6, that's my red inequality here. And I have shaded below my negative 3/5 x plus 10. We see our solution is here in the middle. Now we can determine possible solutions for this situation. So we know any of our solutions in this shaded region are going to be valid for the system, where we're not going to spend more than $25 and we have at least 6 pounds. So we have 6 pounds of flour. So if we have 6 pounds of flour and 3 pounds of cornmeal, that point will lie here, which is inside the shaded region. Another possible solution could be 10 pounds of flour and 1 pound of cornmeal, where we have at least 6 pounds altogether, and we're not going to spend more than $25. So 10 pounds and 1 pound of cornmeal. Notice both of those points are within that shaded region. Any point could be a possible solution. I'd like you to write one more. Next, we have a seafood restaurant owner orders perch and salmon. Perch is $4 a pound and salmon is $3 a pound. He wants to buy at least 50 pounds of fish, but cannot spend more than $240. So we're going to let our x equal our pounds of perch and y equal our pounds of salmon, which means my x-axis is going to be pounds of perch, my y-axis is going to be pounds of salmon. So my system of inequalities is going to look like 4x plus 3y is less than or equal to 240. The cost for the perch plus the cost for the salmon, and we can't spend more than $240, so it has to be less than or equal to the $240. And we want to buy at least 50 pounds of fish, so the total amount of fish has to be greater than or equal to 50 pounds. So we have our two inequalities solved for slope-intercept form. When we graph those inequalities, we end up with this shaded region. We have to choose a solution that's within that shaded region. So two possible solutions are 20 pounds of perch and 30 pounds of salmon. So notice here, I've actually scaled my graph differently. I've scaled my graph where I'm counting by tens. So 20 pounds of perch and 30 pounds of salmon is actually going to be 20 pounds of perch and 30 pounds of salmon. Notice that that point is actually on the line here, which is okay because our inequality has an equal to symbol. Notice that this is exactly 50 pounds, 20 pounds of perch and 30 pounds of salmon. Add together to get 50. That's why it's on the line. But it doesn't have to equal 50. We could have 40 pounds of perch and 15 pounds of salmon. It's still within that shaded region, so it's still valid for the situation. I want you guys to choose one more valid possible solution. This next problem is on your own. Remember to write your let statements. Also highlight important information in the problem. Write the system, graph it, and write two possible solutions. The next problem is also on your own. Write your let statements. Write the system and graph it, and two possible solutions. This next problem and the last problem, make sure you answer all 4 questions after you've written your let statements, written your system, and graphed it.